Welcome back. In this video, we will be discussing two different topics that many introductory students struggle with: temperature and density. Temperature is the measure of thermal energy in an environment. It is unique among all of our chemistry quantities because we will measure it on temperature scales that define zero differently. In the United States, the temperature scale commonly used is the Fahrenheit scale, while most of the world uses the Celsius scale. If we were reporting scientific data such as boiling points, freezing points, and reaction temperatures, we need to be able to readily convert from one to the other. The best way to compare the two scales is look at two important values: the freezing point and boiling point of water. In Fahrenheit, water freezes at a value of 32 degrees Fahrenheit and boils at a temperature of 212 degrees Fahrenheit. The Celsius scale is easy to remember because water freezes at 0 degrees C and boils at 100 degrees C. If we need to convert from one scale to the other, the equation we commonly use is temperature in Fahrenheit minus 32 degrees Fahrenheit times 5 degrees Celsius divided by 9 degrees Fahrenheit will give us our temperature in Celsius. If we start with a temperature in Fahrenheit, the first thing we need to do is subtract the 32 degrees. Once we have done that, we will multiply by the conversion factor of 5 degrees C for every 9 degrees Fahrenheit. And using the steps from the previous video, we see that the units of degrees Celsius remain. The 5/9 conversion ratio is used because the increase of 1 degree Celsius is a larger temperature change than an increase of 1 degree Fahrenheit. An example of this type of calculation would be if I have the melting point of gold and it is 1948 degrees Fahrenheit, what is this temperature going to be in Celsius? I can take my value and plug it in to my equation. First thing you will notice is that I have my 1948 minus the 32. So this will give us a value of 1916 degrees Fahrenheit. Now what we must do is multiply by that 5 degrees Celsius over 9 degrees Fahrenheit conversion to give us our temperature in Celsius. So if we take our 1916, multiply it by our conversion factor, we will get a value of 1064 degrees Celsius. Converting from Celsius to Fahrenheit can be done by manipulating the equation, as was shown in a previous video. We will regularly use the Kelvin scale, however, in chemistry, which is based on the concept of absolute temperature. The minimum value of this scale, 0 Kelvin, is commonly called absolute zero. This is the lowest temperature that can exist, indicating no thermal energy. In this scale, you cannot have negative temperatures. Notice that we do not call it degrees Kelvin, or do not have a degree sign. For example, this value is read as 273.15 Kelvin. Because kelvins and Celsius degrees have the same magnitude, all we do to convert from degrees Celsius to kelvins is add the freezing point of water to our temperature. Kelvin equals degrees Celsius plus 273.15. So that is very nice and useful for when we're going from Celsius to Kelvin. But what happens if we need to go from Kelvin to Celsius? Well, now we can say that degrees C equals Kelvin minus 273.15. Let's try an example using these conversions. A cold day in Texas reaches a temperature of 12 degrees Fahrenheit. What is this temperature in Kelvin? We have to use both of our conversions, starting with Fahrenheit to Celsius. So let us go and get that equation. 12 degrees Fahrenheit minus 32 degrees Fahrenheit. If you'll notice, our parentheses do matter. So if we do this, it is going to be minus 20 degrees Fahrenheit. The next thing that we have to do is multiply by our unit conversion of 5 degrees Celsius by 9 degrees Fahrenheit. This will allow us to get our value in our degrees Celsius. That value is negative 11 degrees C. Now we must convert from Celsius to Kelvin. Remember that all we need to do is add 273.15. So if we need to do that, we will use this equation here. Kelvin equals our temperature of negative 11 degrees C plus 273.15. If we do that, we will be able to record our temperature as 262 Kelvin. This has 3 sig figs ending in the ones place because only sig fig rules that we used were addition and subtraction. The other fundamental property that we will discuss in this video is density. It is a ratio of the mass of a substance contained in its volume. The equation for density is D equals our mass over our volume. Density is a property of any substance. If we have items of similar size, but they have different masses, we know they cannot be made of the same substance because they have different densities. This property is used to test such things as gasoline content, buoyancy, and the purity of gold in jewelry. One difficulty working with density is that we will use many different units for this property. The SI unit for our density is kilogram per meter cubed. These are a little big and bulky and not feasible for chemists. We will typically use density units that depend on what phase we will be talking about. Solid substances are commonly reported with the units of grams per cubic centimeter, while liquids are typically going to be reported in grams per milliliter. This is convenient because 1 cubic centimeter is equivalent to 1 milliliter. So this is actually the same unit. In the case of gases, there are usually fewer particles in a much larger volume. So those units are usually too small for us to use. We are going to use the units of grams per liter in many gas calculations in general chemistry. Let's try a couple of examples of our density calculations. The density of copper is equal to 8.96 grams per cubic centimeter. If a piece of copper has a mass of 225 grams, what is going to be our volume of the copper sample? We have 2 of our 3 variables for our equation, so we can manipulate the equation to get the volume isolated. We will start with our density being equal to mass over volume. We're going to multiply the volume up and divide by density so that we're going to get an equation that says volume is equal to mass over density. Now we can plug our values in. Our mass was 225 grams. Divide that by our 8.96 grams per cubic centimeter. Our units of grams are going to cancel using our rules of unit conversion, and we are left with the unit of cubic centimeters, which is nice for our volume. If we do that, we will get an answer of 25.1 cubic centimeters. Now let's try a slightly harder problem. Octane has a density of 703 kilograms per cubic meter. How many liters of octane are in a gas tank of a car when the octane has a mass of 32 kilograms? This will use our density equation as a unit conversion factor that we can plug into our dimensional analysis calculation. Let's start with our mass. We have 32.0 kilograms of our octane. The first thing we need to do is use our density conversion factor to get it to a unit of volume. Using that from the problem, we can say that 1 meter cubed, we have our volume, so we must use our mass, is going to be 703.0 kilograms. Now what we must do is convert from our meters cubed, which is a very bulky unit, and we must convert it to something else. So now we can say that 1 centimeter of octane is 10 to the minus 2 meters of octane. But we have a problem. Notice that we have meters cubed here and just meters. In a previous video, we showed you what to do with exponents. We are going to take this entire value and cube. This will give us meters cubed, which will allow us to cancel. And now notice that we get cubic centimeters, which is a very nice unit of volume. So the next thing that we are able to do is use another unit conversion factor of 1 milliliter of octane. And we can use our equivalency to say that it is equal to 1 cubic centimeter of octane. Notice that my cubic centimeters from my conversion factor here will cancel out with that part of the equivalency. The last thing that we need to do is go to our desired unit, which was going to be the liter, and that is using 10 to the minus third liters is equal to 1 milliliter. If I do all of this math, and notice that I can cancel out my kilograms, my cubic meters, thanks to cubing that conversion factor, then I need to cube my centimeters cubed. These will cancel. Finally, my milliliters will cancel. All of my units canceled except for the desired unit of liters. When I put all of these values into my calculator, remember to multiply by the top and divide by the bottom. Remember, this term must have the value cubed because we cubed the unit. When I do all of that, I will result in an answer of 45.5 liters. This is approximately about 12 gallons, which is normally what you put into the tank of your car. These two topics are fundamental to physical science, and we are going to utilize them throughout general chemistry.